For 165 million years, dinosaurs dominated land, sea, and sky. Long-necked Brachiosaurus stood 4 stories tall. Mosasaurus stretched 55 feet from snout to tail, and Tyrannosaurus rex tore through prey with 50 to 60 banana-sized teeth. Back then, dinosaurs thrived in the warm temperatures and mild weather of what we call the Mesozoic era. But 66 million years ago, the world's climate drastically changed. Earth became like a Zack Snyder film, much colder and darker. Plants died, food became scarce, and 3/4 of the creatures on Earth, including most of the dinosaurs, went extinct. We still debate what caused this relatively sudden change in climate. 2 popular theories are an asteroid strike and the eruption of a giant volcano. Both theories involve a rare metal called iridium. Iridium is extremely hard to find on Earth's surface, but it does exist in the planet's liquid core and in space rocks like asteroids. Underneath the Earth's oceans and continents, there's a thin iridium layer in what geologists call the KT boundary. That's the point in the geologic record where they see evidence of the dinosaurs' mass extinction. Discovering the KT boundary in the 1980s led scientists to speculate that a 6-mile-wide meteor hit Earth around 66 million years ago. The impact had the force of 10 billion nuclear bombs and would have thrown massive clouds of dust, iridium dust to be precise, and other debris into the air, blocking out sunlight for years. But where were the signs of such a collision? In the late 1970s, a pair of geophysicists found a 93-mile-wide, 12-mile-deep crater on the edge of Mexico's Yucatan Peninsula. It took about 20 more years to suggest that the hole, named after the town of Chicxulub, was an impact crater, and one roughly the right size and age. Rocks in this area may have been unusually rich in carbon dioxide and sulfur back then. An asteroid's impact could have released those compounds into the air and contributed to the rapid shift in the climate. Other clues found in the layers of the Chicxulub crater include quartz with a shocked crystalline structure from the impact, soot that suggests widespread wildfires, and tektites, or rocks ejected from the impact sites that turn into glass. While this evidence leads many people to think a giant fireball signaled the end for the dinosaurs, not everyone is convinced. The iridium layer and strange rock clues, they argue, could also point to volcanic activity instead. Volcanoes went wild during the last 40 million years of the dinosaurs' reign. In what is now Western India, giant cones belched lava drawn up from the Earth's mantle, spewing dust and ash too. After millions of years of eruptions, there could have been enough debris in the air to block out the sun, even without the help of a giant meteor. The volcanoes also could have drawn iridium from deep within the Earth to form the thin layer we see in the crust today. In rebuttal, some researchers argue that the volcanoes would not have changed the climate drastically enough to kill all the dinosaurs. Another theory posits that the dinosaurs were killed off by a combination of both an asteroid and volcanic eruptions. The impact of the space rock could even have made the eruptions worse, hitting the dinosaurs with a geologic 1-2 punch. Or it's possible that the dinosaurs were already withering away, and that a catastrophic event finished them off.